Okay, I've got the top of the hour on my clock. We've got a lot to get through today, so we're going to get started. I want to say hello, everyone. Thank you for taking the time out on this lovely Tuesday to join me. So we're going to talk today about designing stormwater channels using the GEOWEB Channel Protection System. So hopefully this is going to be something that you get some good information out of. And if not, well, oh well. So I'm your host, Sam Justice, and I am a licensed professional engineer in the state of Wisconsin. And I have degrees in civil and geotechnical engineering. I am one of the engineers here at Presto Geosystems, and we manufacture industry-leading erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Throughout an extensive national and international distribution network, we offer technical and site support, as well as free project evaluations from our in-house design engineering team, which I am a part of. So we're going to start today with a good look at what the GEOWEB system is. So what it is, how versatile it can be, and how it can work in a number of different types of situations, including around pipe outfall areas and high flow situations. Then we're also going to take a quick look at some university accredited research performed with the GEOWEB system so that you can understand where we're getting some of our numbers from and how we have the confidence in this system to act the way that it does. So if there are questions during this presentation, everybody is muted. So please use the questions tab on your GoToWebinar menu. And at the end of the presentation, we'll do a Q&A and try and get through some of those questions, make sure we get everybody on board. So we are going to start with a description of what the GEOWEB 3D soil stabilization is, for those who may not be familiar with this type of product. So the GEOWEB system has been on the market for about 40 years. We started this product with the U.S. Army Corps of Engineers in the 1970s, and we've been one of the industry leaders ever since. So the GEOWEB system is our version of Geocell technology. So the Geocell is the terminology for what this material actually is, and then GEOWEB is our specific brand of a Geocell. And so Geocells consist of two main attributes. The first is going to be the cell or the container size. So the cells come in 3 diameters, small, medium, and large, and they have cell heights of 3, 4, 6, 8, and 12 inches. So they do have a defined depth. They are a 3D system. So these dimensions are going to depend on your project details and if you have any specific loading requirements. And so we can help you determine which one is going to be the most appropriate for any specific job. There's no one right answer. There's also 5 section links to best fit your project needs. So it's really important that you have that discussion of which one is going to be the most appropriate so that you get what you need for your project. So the ultrasonically welded seam is going to be where all of the connecting points are. That's going to be really important to the function of how a geocell works. So the stronger this seam strength, the better the performance of a geocell overall. A strong seam allows for heavier infill materials, steeper and taller slopes, and better overall lifetime performance. The GEOWEB system is produced using high-quality virgin high-density polyethylene, HDPE. And so this is done so it has consistently strong welds at every cell junction, while also maintaining some semi-rigid ductile properties within the cell walls. If you have too stiff of a cell wall, it can lead to overstressing of those seams and the potential for cell rupture. So our geocells don't use any fillers or exotic polymer alloy blends, some of the other stuff that you may see on the market, which can ultimately reduce that weld strength and other properties such as the environmental stress crack resistance. So like I said, sometimes these type of fillers or polymers are offered in competing products in the name of increasing cell wall stiffness. So to avoid weld failures and the damaging effects of differential settlement, uniformity in the performance across all of the different elements of a geocell system is going to be much more important than stiffness alone. And so I kind of threw a lot at you right there. And it's not necessary that you remember every single term I just said. If you don't remember that it's semi-ductile, that's not the end of the world. Basically, what we want you to keep in mind and want you to take away from this is that you don't want to overemphasize a single property of the Geocell system to the detriment of other properties, such as that cell wall stiffness. And that's pretty, intuitive, right? You want everything to work in harmony. You want it to be uniform. And that's kind of the term that we're going to keep focusing on today is uniformity. You don't want just one thing to be excellent if everything else is not excellent, because you're still going to see failure in those other categories. So that's why you don't want to focus on just a single property. You want that nice uniform system overall. Okay, so I said there were two main attributes, that cell or container size being one of them. The second one is going to be the infill material, so what you're going to put in those containers. So the three main infill types that can be used with the GEOWEB system are going to be aggregates or granular soils, such as sands, nutrient-rich topsoil to try and grow vegetation, and then concrete. And which one you're going to choose is going to depend on the type of protection that you need from the system. So in most cases, using the GEOWEB system will allow you to use on-site salvaged or site one materials if you don't want to import fill. So if you're doing excavation and you're pulling out, your topsoil, or if you have a granular material on site that you have extra of, you can use that as salvaged material. You don't necessarily need to bring in engineered stone or, specific topsoil requirements if you have something on site. So that ability to reuse the material, very key. So all three infill types can be used when doing protection on slopes or in channels. And when used in channels or flow areas, concrete is going to be best if you know that you have very high flows anticipated. So if you know that you're in perhaps, say, a spillway situation where you have the potential for very high flows over a short intermittent area, potentially concrete is going to be the right option. Otherwise, if you are in an intermittent area or you have lower flows, and we're going to get to some of those specific numbers in just a minute, aesthetics is going to be the driving factor in which material you use, whether it's going to be stone or topsoil with vegetation. Something I do want to point out, I mentioned all of our products are manufactured in the upper Midwest, in Wisconsin and Illinois. So we are made in America. We are Buy America approved. So if you are in the United States and you're working on something that perhaps has federal funding, usually some sort of made in the USA or Buy America requirements might be in place. So we do meet those standards. So that's just something to keep in mind. We are a completely US-based company. We are not importing anything from other countries. We're not doing any of our manufacturing in other countries. Everything's done right here in the good old USA. Okay, and then one more thing that I just kind of want to point out is going to be our specifications for the GEOWEB Geocells. So this is our standard performance and material specification summary page. So you can see there's a lot of information packed into this standard sheet. We don't have time to go through everything today, and some of it gets pretty specific that, again, you don't necessarily need to know every specific number. But I do want to provide you with a sense of what a typical Geocell product specification should look like. And you're going to note that it contains a lot of detail on key material properties, including that weld strength and the environmental stress crack resistance, which are both things that I mentioned before. So just something to have, this is sort of the key material properties of how a Geocell works. And this is what we want to have that nice uniform texture about. We want everything to be in good harmony without overemphasis on a single thing to the detriment of others. And just a general note, when reviewing pretty much any product spec sheets for Geocells or any other type of geosynthetic, you really want to pay close attention to any disclaimers or this fine print language that might be at the bottom of a page. And this is going to be where a provider has the potential to sneak in we call them sort of weasel words, those, well, this is the specification, but it might not meet that in the field sort of thing. You want to avoid that type of language. We have recently noticed a concerning trend where some low-end product providers will present performance data that appears like it's equal to industry standards, but then they add that disclaimer language in the fine print stating that the specifications are subject to change without notice, or the information is shown for general purposes and not intended for design. That tells you that you really can't actually trust those numbers. So just kind of a heads up to watch out for that type of trap, especially if you get hit with a request from a contractor who wants to use a substituted product and claims that they're or equal to something that you might have specified as the project engineer. So our spec sheet contains no disclaimers, no fine prints, none of that, concerning language, and we stand behind our numbers so that you can deliver certainty in the solution as you build with materials that you can trust. So what we offer is going to meet these standards every single time. Okay, so with that sort of background about a geocell, we do offer a complete system solution for erosion control projects. So the system components are going to be all of the supporting accessories that help the GEOWEB panels protect your slopes and channel areas. So I've got a simplified diagram here to show how all of those different system components interact with the GEOWEB panels to form that complete system. We're going to talk about each of these components next. So I'm going to go through this kind of quickly. And I do want to stress when I say the word channel, I am talking about protecting an area that's going to see water flow. And this could be, a full width of the channel, so the channel bottom plus side slopes, just the channel bottom itself, or even just the side slopes, or a slope structure such as an embankment or a dam. So really you have full flexibility here of where you want to place the GEOWEB panels for your project. So the process of building up a channel protection system goes something like this. So to begin, we have our channel, have some pretty standard dimensions. We've got our side slopes. And then depending on what infill material you choose, a geotextile separation layer may or may not be required. So you would put that down directly on your channel. And then you're going to put the GEOWEB panels in place. Note how the panels typically have some sort of crest anchorage at the top of one or both side slopes. This is important both for anchorage and to prevent water from flowing underneath the panels, which could potentially cause undermining. So we have two options for anchoring the panels. The first is to use stakes. You can either use Atra anchors, which are going to be metal rebar, or the Atra speed stake, which is a fully HDPE stake. So these are going to be placed along the face of the channel and then also at the crest. The second option is to use a tendon and crest anchorage system. So all of the anchorage is done through the crest of the side slopes or the crest of the embankment, and you don't have anything along the channel face. So this is really good if you have, say, a geomembrane liner in place that you can't puncture, because obviously then it wouldn't be waterproof anymore. This allows you to still place and hold the GEOWEB panels along the channel bottom and up those side slopes, and then have all of your anchorage be done at those crests. Okay, so then you fill in your GEOWEB panels with whatever desired infill material you choose, that topsoil, aggregate, or granular material, or concrete. And then the GEOWEB system can handle water flow. So it is designed to create a stable channel surface even when the maximum velocities and shear stresses do occur. And we are going to talk about those numbers in just a minute. So most channel projects are going to be what we consider a single layer system. And there's really two ways to do the GEOWEB system, and the single layer is going to be that first one. This is where the GEOWEB panels are laid directly on the channel bottom and side slopes like we just saw in that diagram. You fill them in, or you anchor them in place and then fill them in with your infill material. So this is good for areas where your side slopes are 1-to-1, so 45 degrees or shallower. So you want something a little lower. As long as there's room for the footprint of the channel, it is going to be the most efficient way to protect against erosion with the GEOWEB system. However, sometimes space is limited or the project area is up against some existing structures such as a roadway or home like you see in some of these photos. And so what we can offer is called a multi-layer system. And so this is where along the side slopes, the GEOWEB panels are actually stacked on top of one another to create a GEOWEB retaining wall. And this can be done on one or both sides of a channel. GEOWEB retaining walls can withstand the same velocities and shear stresses as that single layer system, and they're still flexible enough to handle curves and changes in grade. So you're not limited by the functionality of the GEOWEB system if you do need to go through this method, this multi-layer method. It is just a little bit more construction intensive. So this is a really good way to create deep channels or have very steep side slopes. So the GEOWEB retaining walls can achieve approximately an 80-degree face angle. So almost near vertical, not quite vertical, but it gets really close. So if you do need that deeper channel, or if you do have those really steep side slopes, the multi-layer is going to be the way to go. So this really allows for those more complex projects that you might need some help with. Okay, so let's talk about some of those components. If we think back to that diagram, there was one thing that actually wasn't shown on the diagram, and that's going to be the connection device between the individual GEOWEB panels. So the GEOWEB panels cover around 320 square feet. Most likely your project is going to be bigger than that, so you're going to need to have more panels than just a single one. They all have to be connected. So using the ATRA key, this is our patented device that connects the individual panels together to create a single web that's going to cover your entire project area. It allows for faster installation of the system, and it's going to last the lifetime of the project, ensuring that the channel is going to be fully protected and that the system won't fail under anticipated loads or flow velocities. The specific engineering values of the ATRA key are going to ensure that the system holds up over time without the corrosion seen in metal staples or the failure that you often see with cable tie systems. Cable ties usually are not very consistent. Sometimes they break a little easier than you would think they would. With the ATRA key, it's a fully molded HDPE device that is going to be as strong as the GEOWEB panels themselves, so you're not going to see failure along those connecting points. Okay, so next we're going to take a closer look at some of those anchorage options that I mentioned. So if the GEOWEB panels are laid completely flat, gravity is going to hold it in place and you don't need anchorage. However, usually in channels, you do have those side slopes, or if you're on an embankment, you're obviously on a slope. So you are going to need something to help hold the GEOWEB system in place. So for shallow slopes, and for us, shallow typically means shallower than a 2-to-1, so about 26 degrees or shallower, stake anchorage is usually going to be sufficient. So like I mentioned, we have two options for stakes. One made of a standard steel rebar and one made of high-density polyethylene. And that's what's shown in the photo here. That's our ATRA speed stake. So this is really good if you are in a saline environment, like if you're on the coastline where metal would corrode. You would use the HDPE stake because it's not going to have that corrosion or that environmental degradation over time. So it's just an option if you know that you are going to have those environmental challenges that you need to overcome. And stakes can easily be driven by hand or with a power drill for easy installation. So depending on what you need for your site, these are really easy to install. It's not something too difficult. Okay, so for steeper slopes, so if you're getting above that 2 horizontal to 1 vertical angle, or if, like I mentioned, you are in a situation where you're over something like a geomembrane liner that you don't want to puncture, where you wouldn't want to drive that stake through a liner because it would disrupt the integrity of it, you would use the tendon anchorage system. So our ATRA tendon clips transfer the load from your heavy infill material to the tendons, which are those white strings that are going through the GEOWEB panels, and then up to your crest anchorage system. Crest anchorage can be something like a dead man anchor, so a buried pipe in an anchor trench. You can put in earth anchors, or if you do have an existing structure right at the crest of your slope, you could attach to that with concrete anchors. So there's a couple different options for crest anchorage that you would tie off to those tendons. So only the Atra tendon clip is specifically designed to fully transfer, both safely and securely, the forces that are placed on a geocell. So all of our accessories and every feature that we offer has been designed and tested specifically to work together so that we can go from problem to design to construction solution with a single system that really does work based on real world forces. And that's done through extensive research and modeling that we have done to prove that our accessories are going to stand the test of time. So with a basic overview of what the GEOWEB system is, how it can be put in place in those channels or embankment applications, let's dig a little bit deeper into some of the capabilities and functions for each of those infill types that we've talked about. So we'll start with a topsoil fill where it's going to have vegetation, some sort of grass infill. So one of the best things about the GEOWEB system is how much we trust that the system is going to work the way that we say it will. And that's because we do have the experience, like I said, about 40 years. We are the originators and industry leading experts in geocells. And then we also have extensive research to back up what we're saying. A huge series of tests were performed at Colorado State University in Fort Collins under the direction of Dr. Chris Thornton. Colorado State University is considered one of the top hydraulic research facilities in the world. And the facility is actually unique. It's kind of cool. I don't know if any of you know it specifically, but it's located underneath the Horseshoe Reservoir and actually has a couple 100 feet of static head to achieve extremely high velocities and shear stresses in their test flumes. And that's something that you just don't get in a lot of places. So this is one of the best places in the world to try and model real world forces that you can then take to pretty much any type of application. So this was really a good deal for us to be able to get in here and see what we could do with Dr. Thornton. So vegetated infill testing was performed with two objectives in mind. The first was the ability to withstand high velocities and shear stresses, the main components of what you're going to think about when you're trying to withstand water flow. The second objective that we had was that we wanted to compare the performance of vegetated GEOWEB to riprap and other conventional solutions such as erosion control blankets or turf reinforcement mats that are placed by themselves. So the testing consisted of using 6-inch deep GEOWEB panels filled with topsoil and then also using a surface protection method. So in this case, it was an erosion control blanket or a turf reinforcement mat. So this is probably our most recommended cross section, that's 6-inch deep. And that's really because it does allow for deep root growth, that penetration of those roots of that grass and that vegetation to really get in place and hold itself there. You go with too thin of topsoil, sometimes vegetation is finicky and doesn't want to grow properly. So having that 6 inches deep is usually the sweet spot. So a total of 10 one-hour tests were performed with varying conditions, including the flow rate and the bed slope angle, number of different things to try and make sure we're testing all of the different possible configurations. It was done with ASTM D6460, which with soil loss through scour and blade density. So the ASTM standard considers a successful test when you have less than ½ an inch of topsoil loss and you still have at least 300 blades of grass per square foot. So blade density is perhaps not something you would initially think about, but it is important because it really doesn't help anybody if the soil stays in place, but there's no grass growth because all of the blades of grass keep getting ripped out whenever water flows over it. Otherwise, you're just going to end up with a muddy looking channel, which is not anybody's goal. So you want to keep that really thick blade density so that you have that nice full grass growth. It looks like a nice green lawn. So vegetated channels hold up really well, even against turbulent flows, such as around corners or along rough terrain. So most people might not think of vegetated channels being able to withstand that much water flow, but when properly confined within the GEOWEB system, along with using some sort of surface protection, such as a turf reinforcement mat, velocities of 30 feet per second and shear stresses of 16 psf can be achieved. So here you can see one of the tests were being performed. The GEOWEB filled with topsoil and grass is actually underneath that water. You can't even see it because there's so much water flowing through the flume. So that's really telling you how much water you can have over the system. It doesn't just need to be a trickle. It can be a full, flowing channel. So that's actually a really good thing to keep in mind. So one of the things that we always say is I'm not a botanist or anybody who knows anything specific about grass. There are lots of different types of grass to choose from, but choosing either a hardier variety is going to help improve those results. But you also want to choose something that you know is going to grow in your climate. Something that's going to grow really well in the Pacific Northwest is probably not going to grow very well in the Arizona desert. So just something to keep in mind. You want to have something that you know is going to grow in your area. And so this is sort of our results comparison that you can take a look at. Really shows how well the GEOWEB system performs in comparison to some other options, including typical vegetated channels that don't have any sort of protection. So if you just have cut a vegetated swale along the side of your road and are letting water flow through it, you really can't have more than about 4 feet per second before you start getting that significant erosion, grass loss, all of that stuff. Then if you go to the right side of the graph and you use the GEOWEB system and you do have that surface protection on top of it, you're getting up to that 30 feet per second, which is a massive change. So it's definitely something that if you know you have the potential for those higher flows and you don't want to have to come back in and constantly be repairing your channels and trying to plant more grass, anything like that, this is the way to go. You're going to prevent that scour. You're going to keep that blade density. You're going to be able to withstand those flows for a lot longer. So this is a pretty typical application where you can use the GEOWEB alongside of a roadway or a highway. And you could compare it to a standard riprap channel. I'm pretty sure we've all seen one of these. The riprap system just really looks unfinished. It looks like you cut the channel and then left it there, meaning to come back someday. It's going to need maintenance after every major storm event to ensure that there's not significant loss of that riprap material. With the GEOWEB system, you get a nice green area and you can be assured that it's still going to look this good after every storm event. So much less maintenance, much less worry. Definitely a better option. So the system also works good for embankments, pretty much no matter the weather. So in this case, it was done at a gold mine up in Toronto, Canada. So definitely a cold weather environment. Luckily not during installation, but Canada is known for its cold weather. You're going to see lots of rain. You're going to see lots of snow. So in this case, the embankment was on the dry side of a pond that would see infrequent overtopping, but was built with unstable soils because it was an active mine. So it had variable slope lengths and slope angles. So this wasn't just one nice slope that you could cover. It had to sort of contour to the land and fit with what was there as they were building and using the mine. So Toronto, like I said, definitely that cold weather environment, and the GEOWEB system stands up well to snow, frost heave, and ice buildup. So an access road was also going to be built above the embankment where the excavator is currently shown. So the slope had to be stable enough to support that expected road traffic and prevent erosion from potential overtopping down the side of the slope. So when used as an embankment, the GEOWEB system does protect the slope from water runoff and overtopping, and you're going to still keep that vegetation in place. So you're going to get that nice green slope. You don't have to worry about that scour and that vegetation loss. So another thing that's good about the GEOWEB system is when you have space constraints. So if you've got something at the crest or the toe or both, such as that access road, in the last photo, where you can't regrade your embankment, so you're stuck with a steeper slope than you might have wanted, you can use the GEOWEB system even in these space constraints. This is going to help hold that vegetation in place when it normally wouldn't on a steeper slope. Typically on a one-to-one slope, vegetation has a really high chance of scour and sloughing off, not with the GEOWEB system. GEOWEB system is going to hold it all in place, and it can still fit around access roads, highways. You can install fence posts or other types of structures right through the GEOWEB system at the crest or the toe, so that you don't have to compromise the integrity of structures surrounding the GEOWEB system. So it's really good when you know you have these tight space constraints. So this was another slope alongside of a roadway. This was up in Ohio. And this is what I was just talking about. Typically on these steeper slopes, you're going to see a lot of washout. You're going to see failed erosion covers where they might have tried to use something like an erosion control blanket to just sort of place over the soil and hope that it stays in place. And then it doesn't, and then you have washout. And you really want to try and avoid that because you don't want it to wash out onto your road and have lane closures and emergency fixes, that sort of thing. So covering the slope with the GEOWEB system and then filling it in with that topsoil allows for a nice vegetated slope without that concern of having to constantly go back and replace the soil after storm events. In this case, they decided to go with hydro seeding over the top of the GEOWEB system. That's a really great way to get that vegetation to start growing a little bit faster. And the stickiness or the tackiness of that hydro seed also helps hold things in place. So it's a good way to go if you aren't wanting to use a blanket or anything over the top. So the GEOWEB system works really good along the shorelines of stormwater channels. So this was a stormwater overflow channel down in Florida that actually was going to have to withstand hurricanes, because unfortunately Florida is inundated with hurricanes multiple times a year. And so this was a channel that would need to be able to handle that intermittent but potentially very high flow and very high volume storm runoff from hurricanes. So hopefully you're not seeing those very often, but when they were coming through before the GEOWEB channel, there was pretty significant erosion of those side slopes. And you can see there's roads and structures immediately to either side of the channel. So having that worry of erosion potentially undermining the road was definitely not something that the county in this case was hoping to continue. So they wanted to use the GEOWEB system to hold everything in place, keep it within its banks when those hurricanes would come through without having to do that constant maintenance. So the GEOWEB panels in this case are placed along the channel bottom and then up those side slopes up above where they anticipate the water to flow, and then up into their crest anchorage. So the panels go below the water line to ensure that they're not getting lifted up due to wave action. They're protecting your entire slope and your channel bottom from that potentially high flow velocity that was going to be seen in this situation. So the area doesn't have to be dewatered to do this type of installation. You can install the GEOWEB system when it is fully wet, like you see here. The panels themselves will float initially, but then you stake them down. They'll hold themselves to the channel face, fill them in with your infill material, and the system is not going to go anywhere. Typically, when you know that the area is going to be fully underwater all of the time, you are going to choose either concrete or stone, typically stone, as your infill material, because grass doesn't like to be flooded. And then you can transfer to vegetation in those areas above that typical high water line. So you can see here the final surface after the vegetation's been established. You don't see the GEOWEB material, so you're not seeing that black plastic. You are just seeing that nice green grass growth. And the performance of the GEOWEB system allows it to handle fluctuations in that water depth and the associated velocities and shear stresses while still preventing erosion along those side slopes. Like I said, using a soil and a grass type that's local to the area, maybe even using that salvaged topsoil that you might have if you were regrading your channels, is going to be really beneficial, and it's really going to help blend the whole situation so that the GEOWEB panels aren't noticeable. But now you can walk along this shoreline without fears of it sinking in, and this shoreline is going to be protected against erosion for years to come. So definitely a great outcome. And one last thing that I want to point out for vegetated channels, but for other infill materials as well, is that you don't necessarily need to cover the entire channel. You can just do the side slopes or the channel bottom if necessary. So that's pretty common with channels where you know that the bottom of your channel is going to have water flow through it all of the time, so it's already protected against that erosion, and you just want to protect the side slopes against water fluctuation. You would just place the GEOWEB panels along the side slopes. So the panels will allow for that vegetation growth up both of these embankments, which normally might not necessarily be able to do underwater. And in this case, there was this bright yellow liner underneath the panels. So that's why they went with the tendon system. That way they wouldn't puncture through the liner and the GEOWEB panels would be anchored in place. And so even with that liner, vegetation can still grow because you're holding that 6 inches of topsoil within the GEOWEB panels. So now when stormwater overflow causes the channel to become flooded, the side slopes are still going to be protected. The channel can do its job of conveying that stormwater wherever it needs to go. And maintenance on this system is really so easy. Lawn mowing can happen if you have regular grass. So your standard lawn mower, either a walk behind or a ride on, are totally fine. They're not going to damage the GEOWEB system at all. Or if you pick, more of a flowering vegetation, in this case, they chose some tall grasses that don't need to be mowed. They don't need to be, landscaped. Now you don't have to do any maintenance with it at all. So it really is a place it and forget it type of system, which is definitely not a bad thing. Okay, so that was a lot on vegetated infill. So let's move to our next infill type, which is aggregate or granular material. So again, back to testing at Colorado State University. We did both their indoor and outdoor flume testing. And the main objective for this one was to determine how much the GEOWEB confinement can aid in reducing riprap size. So we looked for how well the aggregates can stay in place during the test to determine what rock size would prevent washout, because the system doesn't work if it picks up the stone and washes it down the channel. But really, we're trying to move from those 12, 14, 16-inch large riprap cobbles down to a typical crushed aggregate, somewhere in the 1 to 2 inch range. So the results are actually pretty impressive with the GEOWEB system. If we remember when we were talking about the vegetated system, it allowed for velocities of around 30 feet per second, which is actually higher than what it can do with stone. With stone infill or granular infill, it can see velocities of around 18 feet per second. So this might seem counterintuitive, but you have to think about it like this. You have the strength of a properly rooted full grass lawn compared to a single stone. And that's really what you're comparing, is how well does all of that soil stay in place versus what flow can it withstand before a single stone gets picked up and washed away. So that makes it a little more understandable as to why the velocity would be lower for a stone infill, because you're not considering it as a whole, you're considering each individual stone particle. But the main objective here was the determination of reduction in riprap size due to the GEOWEB system. And also something to keep in mind is that vegetated channels can only withstand water on an intermittent basis, otherwise your grass is going to flood and die. So if you do have continuous flow, aggregate is going to be the right option. So even if it has a lower max velocity, it definitely still has its place on why you would choose it for protecting your stormwater channels. So Dr. Thornton at Colorado State University put together a design tool based on a complicated regression analysis, so we can compare that reduction from large conventional riprap to crushed aggregate confined within the GEOWEB system. So the tool is based on all of the testing data that they had for us and allows us to predict the rock loss and the rock size based on project-specific hydraulic conditions. So the regression analysis is a lot and not necessarily the most important, but what it comes down to is we can recommend the appropriate cell size and depth, and then also the rock size for a specific individual project so that you can be confident that the aggregate placed isn't going to be washed away. And so what you can do is you can see how the size compares to before and after using the GEOWEB system. So this project uses a 2-inch crushed aggregate confined within a 6-inch GEOWEB. And then the tool also compares the GEOWEB solution to riprap sizing for both the Johnson method and the U.S. Army Corps of Engineers design formulas. And so you can see how the size compares. So a 2-inch stone versus a 10 or even a 16-inch stone. So for this job, that stone reduction size was between 5 and 8 times. So that's pretty significant. It's definitely something that you would want to consider if you have to truck in a lot of material. It's a lot easier to get smaller crushed aggregate than it is large riprap cobbles. So the Minnesota DOT, actually, excuse me, not Minnesota, Missouri DOT used the GEOWEB system to help stabilize the surface around bridge abutments and then also along railroad tracks and crossings. So the flexible nature of the GEOWEB panels means that it can easily contour to the slope face and also around obstacles such as piles and abutments. And with the system in place, the water erosion is prevented around those abutments, reducing your overall maintenance costs. So this entire project was actually a mixture of topsoil with vegetation and aggregate infill, with the aggregate being used below the bridges where that vegetation would have been difficult to establish. So they were able to go between stone and soil where they needed it. So like I said, they also used it along railroad tracks and along railroad crossings. And so like I said, the nice flexible nature allows it to go around those abutments when they are kind of unique shapes like they are here. And what it's going to do is it's going to help prevent that water flow from tearing all of the soil or the stone around those abutments, because it's just going to flow over the top of the GEOWEB system. This way you don't have washout of your stone or your soil onto those railroad tracks, so you don't have any interruption in service. Always a good thing. And you can also just handle a lot more complicated slopes than you would with just riprap stones. Riprap stones need pretty specific conditions to be able to hold themselves in place on large and steep slopes. And with the GEOWEB system, you just have a lot more flexibility for the slope angle, how well or not graded the slope face is, and then also going around the abutments. So this was a project along the Gila River Indian Reservation south of Phoenix in Arizona. So heavy runoff from intense storms were leading to erosion and flooding in some of the adjacent subdivisions for this area. And several existing embankments and channel sections had recently failed under a 100-year storm event. Repair time was critical to reduce that flooding and prevent further runoff. And this channel was actually approximately a mile long, and it routed water from the embankments to detention ponds and then other natural drainage areas. So the channel area was cleared of any existing vegetation and then also debris from that 100-year storm. And then the sand subgrade was regraded and compacted into their channel shape. So to prevent infill loss, a non-woven geotextile was placed between the sand subgrade and the GEOWEB panels. This helps prevent the stone infill from migrating into that sand subgrade. You really want the stone to stay within the GEOWEB panels and not get lost underneath the system. And that non-woven geotextile just helps hold everything in place. So the channel was actually very wide and had quite shallow side slopes. Excuse me. So they were able to use stake anchorage rather than needing to use tendons. So that made installation a little bit easier for them as well. And one of the really nice things about using the GEOWEB system is that it does allow for adjustments. So here you can actually see a reduction of the GEOWEB cell depth. It started out at 8 inches on the left and went all the way down to 4 inches on the right. So the second half of the channel away from the main inlet was subjected to significantly lower flow rates. And so because of this, less protection is required. So a shallower GEOWEB panel was used, which saved on cost and installation time. You need less materials to fill it, and it still was able to meet performance requirements. And so this is really only possible due to that strength of the ATRA key. And so that's the connection device that I mentioned way back in the beginning. If you were to use something like staples or zip ties, neither of those have the strength to be able to withstand a reduction in size like this. And so eventually the panels would have separated over time, creating a potential failure area. And the GEOWEB panels are really flexible, and they can easily be cut in the field to allow for things such as pipe penetrations. So here you can see some drainage pipes from a nearby detention pond. And it's really simple to field cut the GEOWEB panels to accommodate structures such as these. So there's no areas left unprotected. And the area right below the drainage weirs should be built up more robustly. This is going to be an area with the potential, highest potential for stone washout, because you're going to have turbulence coming out of those pipes. It's also where the flow is going to potentially be the highest. So definitely consult your hydraulic engineer to find where those areas of concern are, and we can adjust the GEOWEB system to make sure those areas are fully protected. They were able to use some waste rock from a nearby quarry, and really waste rock is not typically great quality, but that's okay. Like I said, you can use those salvaged or those Site 1 materials because you don't need the expensive stone. You just need something that meets your size requirement based on that regression analysis that we had talked about. So it really can help save on material and hauling costs if you have a local source of stone. So pretty easy. You can actually even use this to drive on and act as your access road. You can see that in the left-hand photo. It's actually a dump truck that's capable of driving on this system. So if that's something that you are interested in, definitely let us know. There's a lot of information about using the GEOWEB system as load support for building access roads. I'm not going to be able to get into that today, but if you do have projects or questions about that, more than happy to talk about it. And then here's what it looks like with water flowing through it out of the drainage weirs and then into sort of the natural drainage area where it's no longer protected with the GEOWEB system. So it really does quite well in handling the flow velocities out of those turbulent areas, slowing that velocity down so that it can be drained into your natural drainage without excess erosion, all of that good stuff. So lots of flexibility allowed with the GEOWEB system. Okay, and then our last infill type is concrete. So this is going to be, your fully impervious hard armor protection system. So again, testing was done at CSU, did a number of tests, and we actually maxed out their flume at 36 FPS. That's as high as their flume can handle. So that's definitely not the maximum that the GEOWEB system can allow. Really, there is theoretically no maximum velocity. So if you know you're going to have those really, really high flow events, concrete is going to be the way to go. But basically, there's no degradation of the GEOWEB panels or the concrete within them, and no loss of soil underneath the concrete. So there's no undermining happening. So both really important factors in how you would place a concrete system for this type of application. We do want to point out that the GEOWEB system is the only geosynthetic, including articulated concrete blocks, turf reinforcement mats, erosion control blankets, gabion baskets, any type of geosynthetic. We're the only one to actually max out the flume at 36 FPS. So we are very confident that this is going to work for even the most challenging of projects. So concrete filled GEOWEB is going to be used, best used when there's going to be that really fast water flow. So this was a channel project that takes water runoff from a train intermodal yard down in Texas. The GEOWEB system replaced a design that had 6 inches of reinforced concrete channels plus 4 inches of grout bag slope protection. The GEOWEB was a value engineered solution due to cost overruns. So we were able to take out that 6 inches of reinforced and replace it with the concrete filled GEOWEB system, which ended up saving several $millions in installation costs, but also importantly sped up construction and allowed the yard to be in service about a year faster than originally planned. So also a great benefit for the client. So the side slopes used 3-inch deep GEOWEB anchored with stakes because it was relatively shallow. And then the bottom used 4-inch deep GEOWEB. So again, you have that flexibility to go from one depth to another as necessary. And they went with the 4-inch GEOWEB again, so it could support vehicle access. So like I said, if you do have questions about that, definitely something we can help with. So GEOWEB panels act as the form for your concrete, so there's no need to build additional formwork, which can be tricky on slopes and is definitely something that extends construction time, so it's nice to not have to deal with that. You pour the concrete from the top to the bottom and then make sure it gets in all of the cells. And then those cells hold the concrete in place and prevent it from slumping or creating areas of uneven thickness. And speaking of thickness, the GEOWEB has that advantage of ensuring a consistent placement thickness across your entire project area. Excuse me, pore pressure buildup is always a concern underneath concrete structures, and it is here as well. So we do recommend doing something to address pore pressure buildup. That could be including things like drilling weep holes into set concrete, including drainage pipes before you pour in the concrete. You can install those through the GEOWEB panels. Number of different options that we're happy to give our advice on, but definitely something that should be considered, always considered when using concrete for structures. Then here you go. So here's the full extent of the project. It was more than 1 million square feet, so pretty significant. And it saved the railroad a significant amount of time, money, and installation costs. So all good things. Okay, last little thing that I want to highlight are 2 kind of special cases. This is including areas around outfall pipe areas and then incredibly high flow situations. So outfall areas can be challenging because they typically have higher velocities and higher shear stresses than the channel is going to see as a whole. The water in these areas is usually turbulent rather than a nice smooth laminar flow. And turbulent flow is going to cause its own set of problems that need to be considered. So using the GEOWEB system can help mitigate some of these concerns, especially when concrete infill is used, since turbulent flow and high velocities aren't going to be an issue when concrete is used. So the option to mix infill types, going from concrete to stone or concrete to soil, is going to be really helpful when you know you have to protect against these areas. So use concrete around the outfall area and then transition to something else for that more aesthetic appeal when you know that you've reduced your flow enough. The GEOWEB system can also be used in conjunction with riprap. So if you don't want to use concrete, but you know you have those higher flows, you can still bring in your nice high riprap stone. And so this was a culvert outflow in Wisconsin. So a stronger surface protection, in this case they used a core fabric, which also helped prevent erosion within the GEOWEB system, but you can see they were able to sort of terrace it back, create that nice vegetated system, and still use the riprap stones for those short duration but high intensity events, and then have the GEOWEB system with vegetation protect against potential very high flows. Okay, and then the other special condition are incredibly high flow situations where you need to slow that water down. And so when you do need to have it slowed or even stopped because potentially you're going into a natural drainage area that can't handle high velocities, one of the best ways to do that is with energy dissipators. So energy dissipators can be added to any concrete filled GEOWEB channel, and they can be as low tech as simply placing boulders over the panels to something a little bit more uniform where you have a nice patterned layout of dissipators, but they can definitely be included as necessary. So they can be placed on both shallow and really steep slopes, same as the GEOWEB panels themselves. And utilizing a tiered channel system like this can also help limit the height and the angle of the channels, which can help with installation concerns while still containing and directing your water downslope. These dissipators were actually pre-formed off-site and then brought in. So they were installed within the cured concrete by doweling in and then providing an epoxy bonding agent. So you have that option of either to install them during the GEOWEB installation or at a later time as necessary. So the number of dissipators, the size, the spacing, all of that is going to be dependent on your anticipated flows and your channel conditions. There's no one right way to include energy dissipation, but it's definitely something that myself and the engineering team here at Presto can help with on a case-by-case basis. And so here you can see some of the impressive turbulence energy dissipation and how that aids in the reduction of the flow rate through the channel. So the bottom line is with energy dissipation, where you need that water to either be very low or zero flow rate by the end of the channel, energy dissipation is going to be the way to go. So if it's something that you need, feel free to reach out. We're happy to help see how it can be included in the GEOWEB system. Okay, so we've reached the end. Summary. So the GEOWEB Channel Protection System has great flexibility of design. You can have a variety of infills to meet your specific project needs. So we can fill with topsoil to get vegetation, nice green grass growth. You can use crushed aggregate if you're in an area where grass is not appropriate or if you're fully underwater. And you can use concrete to help protect against high velocities or if you have that turbulent flow. So all of our experience evaluations is backed by about 35 years, 40 years of experience and extensive research and testing. We stand behind our numbers. We're really confident that the GEOWEB system is going to be something that can perform well for your project needs. So if you are interested in the research that was done at Colorado State, if you are interested, I do recommend reaching out. We can provide these summaries. It's actually kind of interesting stuff if you are into hydraulics in any way. And Dr. Thornton is a world-renowned research scientist in this field. It's really a good thing to have his backing to really be confident about this material. So we can provide this information if you have any questions about any of the three main infill types. So part of our complete solution is that we provide technical assistance. So the engineering team here, including myself at Presto, we work closely with landscape designers, engineers, contractors to basically offer our recommendations. So it's a free project evaluation. It can be done for embankments, channels, or any of the other type of systems that the GEOWEB system works for that we didn't necessarily get to today. So we do have a form on our website. It's called Free Project Evaluation, our website at prestogeo.com. You fill it out with as much information as you have, including attaching documents such as geotechnical reports, site pictures, if you have plan sets already in place, all that stuff comes directly to us so we can review it. Then within just a couple business days, our in-house design engineering team provides a complete design evaluation. So we're going to give infill recommendations, any anchorage requirements that you need, whether you should go with stakes or tendons. We're going to say whether or not we recommend using a geotextile underneath the system, all that good stuff. And so we're going to work with you to get you the best design for your specific project. We're not just trying to sell you something, we're trying to get you something that's really going to work for you. And just another quick summary of our spec sheet here. We do deliver quality, 40 years of expertise, guaranteeing each shipment meets or exceeds our specifications so that you can deliver certainty and build with materials that you trust. No disclaimers, no concerning fine print. One last thing I want to cover really quickly. It's always one of the biggest questions we get. It's going to be about cost. No surprise there. Everybody wants to know how much things cost these days. So especially if this is a new technology for you or your area, having an idea of how much the GEOWEB system might cost compared with other stabilization techniques is really important. So this is a basic cost-benefit comparison that we have for the GEOWEB system for load support applications. So not specifically what we talked about today, but you get the general idea for it. So in this case, it was for a gravel surface road, and the comparison shows both the difference in price and cross-section depth for an aggregate only unreinforced section, a section using geogrids and geotextiles, and then 2 sections using the GEOWEB system, one with an engineered aggregate that had to be brought in, and one using salvaged or on-site materials as the infill. So you can see that the GEOWEB system is both thinner and cheaper than any of the other methods, and significantly cheaper if you're able to use those on-site materials. Of course, your mileage may vary in terms of excavation and stone costs, all that good stuff, but this is a good starting point. It's definitely something, if you are interested, you can use this to try and justify how using the GEOWEB system might be beneficial for you. And then a little bit of housekeeping. So we have made it easier and faster for you to obtain your PDH certificates. So with our webinar dashboard, you can easily view our library of webinars and download the PDH certificates for any on-demand webinars that you've completed. Our webinar dashboard will keep a record of which on-demand webinars you have watched, along with any PDH credits earned. Please note that certificates for the live webinars are managed separately from on-demand. So if you are watching live today on Tuesday, November 15th, you will receive a PDH certificate from GoToWebinar within approximately 24 hours. If you're watching this on the webinar dashboard anytime after that, you can download your PDH certificate through the webinar dashboard. So if you're watching live today, keep an eye out, maybe check your spam folder for a email from GoToWebinar for your credit. But yeah, good stuff. You've earned a 1 PDH credit for listening to me today, so definitely keep up the good work. And that's it for my presentation. So thank you so much for attending. I know I went a little bit over time, so I appreciate anybody who was able to stay with us. Please feel free to go to prestogeo.com for a wealth of information. And don't forget to view our YouTube videos found by clicking on the little YouTube icon in the upper right corner on our webpage. Like I said, you're getting those PDH credits either from GoToWebinar or from the webinar dashboard. And we are hosting more of these in the future, so keep an eye out for other emails from Presto Geosystems announcing future webinars. If you do have to go, because I went over, thank you so much for attending. If not, I am going to do a quick Q&A session here for a couple minutes. We had looks like some good questions come in, so I want to get to those. This webinar has been recorded, so it can go up on that webinar dashboard. The Q&A session will be recorded, so if you need to jump off, feel free to get on the dashboard in a few days, skip to the end of the webinar, and you can hear our Q&A now. So let's get to some of those questions, because it looked like there were some good ones that came in. So do we have material specifications for the aggregate or the topsoil directly? So not specifically. So we are the manufacturer of the Geocells. That's what our specification is for. We give recommendations for the type of stone or the type of topsoil and vegetation, that sort of thing. But it is something that is ultimately up to the project engineer to choose. There's not a lot of limitations in the type of soil. Really, you just need something that grass is going to grow in. And like I mentioned, you just want some type of grass or small flowering vegetation that you know is going to grow in your climate. For stone, we do give that aggregate size based on that regression analysis to determine what's that appropriate stone size. And then it's up to the project owner to get that stone, excuse me. But, you can use granite, you can use crushed limestone, you can use crushed concrete, salvaged concrete, that sort of thing. So there's not a lot of limitations there. If you do have questions about whether or not your infill material is going to be appropriate, feel free to reach out. Always happy to give our sort of go, no go manufacturer recommendations. Okay, so a couple questions about using impermeable liners. So yes, you absolutely can use impermeable liners, geomembrane liners, anything along those lines, that if you don't want any sort of flow through them, they can be completely impermeable, or they can be like filtration fabrics if you are going that route, if you're in some sort of detention pond. But yes, essentially you can put any sort of liner structure underneath the GEOWEB system with no issues. This is where we would recommend our tendon anchorage system, so that you can anchor the GEOWEB system without puncturing that liner, but it's not going to impede how the GEOWEB system works if you do have that liner underneath it. So definitely, if you do have questions about that, we're more than happy to give our recommendations on what type of anchorage is necessary, anything like that. We will sometimes recommend putting a non-woven geotextile over the liner underneath the panels, especially if stone infill is being used. That gives a little bit of a cushion during the installation process so that the stone doesn't accidentally puncture the liner. So we can talk about that sort of thing. But yes, it's definitely possible and fully recommended if you need it to put an impenetrable liner underneath the system. Let's see, a couple questions about anchorage with the road washout, or just what that crest anchorage is. And so that's definitely a good question. It's something that is, again, going to be that project specific. But basically, when you are in a, along a roadway or in some sort of confined area where you don't necessarily have a lot of construction space, you have a couple different options for your crest anchorage. This is where you're going to, again, have those tendons that are running through the GEOWEB panels, and then they need to tie to that crest anchorage because that's what's actually going to be carrying the load of the GEOWEB system. Our typical recommendation is a dead man anchor. So this is typically a closed wall PVC pipe that's buried in an anchor trench. Excuse me, typically just buried with soil. You don't necessarily need to concrete over the top of that anchor trench. But you would tie the tendons around that dead man pipe and then bury that pipe, and that would be the thing that would support your load. A lot of times along roadways, you're in those confined environments. You don't necessarily have the space to dig out a full anchor trench. In those cases, we would typically then recommend using earth anchors. So something like a duckbill anchor, platypus, gripple. There's a number of them out on the market that are all available that do the same thing. But these don't need a full anchor trench. They are significantly more space constraint friendly. And so you would tie your tendons to the earth anchor, embed the earth anchor at the top of the crest, and that would hold the GEOWEB system in place, above and below a road, however you need it in those sorts of conditions, to prevent that washout onto a road. So those are just some really high level overview. Like I said, it is all sort of project specific. So there's, again, no one right answer, but there are a number of answers that could be appropriate that we'd be happy to talk about with you. Let's see. When using the vegetated system, do you recommend using a fabric over the top? So sometimes, yes. So there are some pros and cons to using a fabric over the top of the system. In our case, fabrics usually mean erosion control blankets or turf reinforcement mats, sometimes core fabrics. And all of them have pros and cons to the type of fabric you would use. You might not necessarily need it at all. You could just let your grass grow naturally. You could do hydro seeding to try and get the grass to grow a little bit faster, but then you wouldn't have anything left over once that grass is in place. So really, when you would want to start using a fabric is when you know that you're going to have either higher flows or more continuous flows. And those fabrics just help hold the soil within the GEOWEB system while still allowing grass growth. ECBs, TRMs, core fabrics all allow grass to grow up through them. It doesn't impede the grass growth in any way, but it does, sort of stay in place longer term. That gives you just that little bit of extra protection against higher flows, turbulent flows, or more continuous flows. So there are definitely reasons why you might use them, and we would definitely provide that in our recommendation evaluation as to whether or not we recommend you need a fabric or not, what type of fabric, that sort of thing. So they're not always necessary, but they definitely have their place. So let's see some other questions. So how long does the GEOWEB material last? So that's actually a really good question. So the GEOWEB material is high density polyethylene, HDPE resin. So it's a chemically inert plastic. So it's not going to have degradation due to environmental conditions. So if you are in a saline environment where you maybe have salt water, or if you're in a high pH soil area, or if you're in a detention pond that's got some sort of chemical water runoff, none of those things are going to negatively affect the GEOWEB panels themselves. They're not going to cause it to become brittle. It's not going to cause it to break down. You're not going to see like little pellets of plastic coming off of it because of that for any reason. And they are UV stabilized. So you're not going to have any degradation due to being exposed to sunlight or the elements. So it is a really safe plastic to be using in the environment. You know, you're not going to be releasing microplastics or anything like that. We've been doing this, like I said, for about 40 years, so we can guarantee 40 years. But HDPE has been tested in the lab extensively all over the world and has lifetimes of greater than 150 years. So it should be more than sufficient for pretty much any type of project that's being put in place nowadays. So definitely, it's going to last the lifetime of your project. We can say for certain 40 years, but it's really going to be much longer. So I've gone way over my time, so let's do one last question here. So let's see, could you, what's the performance information based on wave action? So yeah, wave action is definitely a concern, especially in these sort of channel environments where potentially you have fluctuating water levels, you might have turbulent flows if you're going around corners, curves, that sort of thing. So it actually holds up very well against wave action, as long as it's within the parameters that the infill material can handle. So if you've got high wave action with a stone infill and you're starting to see turbulent flows that are over that 18 feet per second velocity, that's going to cause a problem. You might want to switch to a concrete infill that way. But if you have the fluctuating water levels because of the wave action, that in itself is not a concern. You don't need to have, a smooth laminar flow at all times. Having shallower slopes on your side slopes can help protect against wave action, just helps hold everything stay within the GEOWEB panels a little bit easier. Lower recurrence, lower periods between waves also is going to be more beneficial. It is going to be, as I keep saying, a project-specific thing as to the specific waves that you can handle. But we have installed this along coastlines in the US and around the world, and have seen great success against coastline wave action. So typically within a detention pond, a stormwater channel, inland lakes, that sort of thing, you're not going to see wave action that's going to cause significant detrimental effects to the system. So that's that's probably the best answer I can give for that at the moment. But if you do have specific questions, or if you know that you have specific hydraulic data, we are more than happy to look at that and discuss it on a one-on-one basis. So thank you everybody who has stayed for questions. If I didn't get to your question today, I apologize. Please feel free to reach out to me. My info is on the screen, or you can go through our website. If the question hasn't been answered on our website, you can email us from there, or you can email me directly. I'd be happy to discuss any questions or projects or just general knowledge with you guys. And I hope to see you in a future webinar. So everybody have a great day. Thank you so much for attending. Bye.